Polar coordinates. We kind of dealt with these ideas already if you guys haven't had polar coordinates before. We have dealt with the unit circle. So this kind of follows that same sort of thinking. So when I take a look at this line right here, that line right there is actually the polar axis. That's where I start my angles at, just like when I talk about the unit circle. So let's say I was going to pi halves. I would take this and I would go all the way to there. So that angle, we call it theta, would equal pi halves. So if I was talking about an ordered pair of polar coordinates, let's say this went up 1, 2. So then my ordered pair for this would be r theta. That's how we set up our ordered pairs. So that's going to be 2 pi halves. So that's how it works to actually graph these. And in the center here, this is the pole. So 0, 0 is the pole.
Yes.
So something to keep in mind as well. Does it come up a lot? Not really, too much. So now if I gave you the ordered pair, and I'm going to do it in a different color so we can keep the differences here. Let's say I gave you the ordered pair 5 negative pi thirds. So now keep in mind here, this theta here is in the positive direction, and that's why I went counterclockwise. So now what we're going to do is we're going to take this negative here, and we're going to go the other way now, because it's negative, so pi thirds is what we would call 60 degrees. So it would actually be here, and then it's 5, so I go 1, 2, 3, 4, 5. So it's going to be way out here, and it's this point. Now keep in mind, when I'm actually dealing with polar coordinates, they're actually resulting in points. So something to kind of keep in mind for these. So this is just another way for us to graph points, and they call it polar coordinates. So now let's take a look at the point -3, pi halves. So that means I would kind of follow the same pattern. So I'd go this way to pi halves. And then since this is a -3 for my radius, this means instead of going in this upward direction, I would actually go in this downward direction because it's in the opposite direction, and that's what the negative does. That negative makes it the opposite direction. So I'd go in that direction, 1, 2, 3. So there would be my point right there. So as you can see, we can have negative radiuses now, or radii, and our angles still kind of work the same as it did with the unit circle. Now let's talk about polar coordinates in terms of converting. So take a look at this here. So this right here, I'm just going to show you where these come from. So if you look to the right here, these are the polar coordinates, and this is how we actually convert those polar coordinates into x's and y's here. We can turn them into r's and thetas here. So we're going to kind of use these formulas to kind of go back and forth between polar and rectangular. Rectangular meaning my x and y values of my ordered pairs. So, or we can talk about those in terms of actually equations too. So getting equations in terms of r's and thetas, or equations in terms of x's and y's. So the first thing I kind of want to show you is just where do these polar coordinates come from. So take a look at this here. So here to the left here, we have a triangle here. And what we're going to do is we're just going to take this triangle, and I just want you to see what's going on here. So looking at this theta here, so if I take this sine of theta, I can say that the sine of theta is going to be opposite over hypotenuse. So that's going to be y over r. Now, if I was to solve this thing for y, I would multiply both sides by r, wouldn't I? So an r here and an r there. Those cancel. I actually get y equals r sine of theta. And if you actually look at this first or I should say this second equation here, that's exactly what we see here. So it comes from just the idea of what the trig functions are in terms of a triangle. Now let's take a look at the other one. So the other one would be the cosine of theta. So I would say the cosine of theta equals, and that's going to be adjacent over hypotenuse. So that's going to be x over r. So in a similar way, if I solve this for x, I'm going to get x equals r cosine theta because I'm going to multiply both sides by r. Okay, so that's where those come from. Now think of the idea of tangent of theta. So if I look at this tangent of theta, okay, tangent of theta is, what is tangent of theta? Tangent of theta is sine of theta over cos of theta, isn't it? Yes. So take a look at this. So would you guys agree that the tan of theta equals sine of theta over cosine theta? And could I multiply both an r by both the top and the bottom? I could, right? Right? That's just multiplying it by an ugly 1. And then if I think of r sine theta on top and r cos theta on the bottom, just think about what we had previously. So I know y equals r sine theta, and I know x equals r cos theta. So this would end up being, y over x. And that's what we see here for this third one. So in essence, we just kind of use the other ones to get the ones after this, the first two to get the last two. And the same thing here. The idea of this comes from, if I take x squared plus y squared, now if I take this x squared here and I square it, I'm going to get r squared times cos squared, right? And then if I add that to this one squared here, then that's going to be r squared sine squared theta. And what ends up happening there is I end up getting x squared plus y squared equals r squared if I work that out. So it's something for you guys to do. This is just kind of an intro of where everything comes from. So in the next video, we're going to get started with working with problems.